All right, there's an important concept in chemistry that we like to summarize as like dissolves like. So note this is opposite of charge. So, when we're talking about charges, it's opposites attract. When we're talking about polarities, it's like dissolves like, or like mixes with like. So polar things will mix or dissolve other polar things. And the same thing is true with nonpolar, right? Nonpolar, and I'll do these little dots just means basically copy the word from above because I'm too lazy to rewrite it. Other nonpolar things, right? So if you've got two polar things, they'll go ahead and mix or dissolve one another. If you have two nonpolar things, they'll mix and dissolve one another. And then finally, if you have polar plus nonpolar, there'll be no mixing. So the most classic example of this is water and oil. So from your kind of everyday life experiences, most of you know that water and oil do not mix with one another. And that's because water is quite polar. Right, due to its bent shape and polar bonds. And oil is mostly made out of carbon-hydrogen and carbon-carbon bonds. And so both of those bonds are non-polar. Remember, we said carbon-hydrogen bonds, not polar. Carbon-carbon, the same element, so that's obviously non-polar as well. And so you can see we've got a polar and a non-polar thing, so we have no mixing occurring here. Note that ionic compounds, we can think of them as kind of superpolar, NaCl, because we have a full-on charge there. So we can think of them as being superpolar. So they will dissolve in polar compounds. So for example, table salt, NaCl, will dissolve in water, right? You can make salt water, but if you try to put some NaCl in some oil, it's not going to dissolve away because the salt, you can think of that as very polar and the oil as non-polar, so they do not mix. Cool. So overall with this part, we've learned really how to draw structures, and now we're starting to learn how to predict their properties based on those structures.